6.5. Graph square root and cubic root functions. Vocabulary. Radical function. A radical function contains a radical, which is a root, like y equals square root of x, or y equals cubic root of x. Remember, we can also use these as a fraction. X to the 1/2 is the same as square root, and y equals x to the 1/3 is the same as a cubic root. So we're going to learn how to graph those. All right, the parent functions for square root and cubic root functions is square root of x. The domain is numbers that are equal to or greater than 0. And the range is also greater than or equal to 0. So they're only positive numbers. The parent function for a graph of cubic root functions is all real numbers. So these will have some negative side in them too. So let's graph it. Okay, example 1. Graph y equals 2 times the square root of x. And then compare it with the graph of y equals square root of x. Well, let's go ahead and graph y equals square root of x first if we want to compare it. So how about if we put in 0 for x, what do we get out for y? 0. What if we put in a 1 for x, what do we get out for y? Well, 1. Okay, how about a 4 for x? What do we get out for y? 2. So 1, 2, 3, 4 is 2. So this graph, the y equals square root of x, goes like that. Remember, we have to stop at that 0 because I can't put a negative 1 in here because I can't have negative square roots. Now, let's graph the y equals 2 times the square root of x. So it would be, if we put in 0 there, it would be still 0. If I put in 1, it'd be 2. If I put in a 4, it would be 4. And if I put in 2 with my calculator, I get about 2.83. And a square root of 3 with a calculator times 2 is 3.46. So this is 0. 1 is 2. And then 2 is almost 3. 3 is about 3.5. And then we have 4 is 4. 2, 3, 4 is 4. So it goes up like that. Okay, so it's just like a the shift with a quadratic, it pulls it closer to the y-axis. Okay, let's go ahead and look at the next page. All right, graph a cubic root function. So we're going to make a table and put the values in and compare the graph of y equals cubic root of 3. Well, let's go ahead and do the cubic root graph first. So if I put in a 0 up here for x, what do I get out for y? 0. If I put in 1, I'll get a 1. Let's see, the first real pretty cubic root I have is 8. And then I'll get out a 2 because a cubic root of 8 is 2. And then what's the next one? 3 times 3 times 3, 27. Okay, I would get 27. Get 3. So 0, 0. 1 is 1. 2, or 8 is 2, so it would be something like that. Now, how about negatives in here? Can I put in a negative? What if I put a -1 under here? What 3 things multiplied together would equal -1? Right, -1. So this does have negatives. So it would come out like this. Okay. Now, to graph the shift version, which is actually a stretch, I'm going to do the same thing. I'm just going to put in values that I know using my calculator and stick in a -2. And so the cubic root of -2 is times -1/2 is 0.63. I'm just sticking this all in my calculator and getting out these values. Okay, and then when I graph this one, it's going to flip everything around. So -2 is about a little over a half. -1 is a half. So do you see that it's going to do like that? Because the negative sign here flips it over, and then this makes it closer or farther away from the x-axis because it's a fraction. Okay, kind of strange, but it's really not that hard. Okay, go ahead and do these 2 checkpoints. This is a cubic root, so you're going to have negative numbers. This is a square root, so it's only going to be 1/2 of the graph. Now, you will have negative numbers on here because let me do 1 point for you. If I stick in a 1 for x, what do I get out for y? -2. So it's going to be down here. Okay, and then start the video again when you're through. Okay, graphs of radical functions. Here's our h and k shifts. And it works the same way as it did in the quadratics or the absolute value. This sign needs to be a negative, and if it is, we can pull out that positive h. And this sign needs to be positive, and we can just pull out the positive k. And then we can do the shift from the parent function. So the first thing you need to do is sketch in the parent function, and then translate the graph h units horizontally and k units vertically. So let's look at how to do this on example 3. Okay, sketch the graph of y equals 3 times the square root of x. Okay, so if I have 0 in for x, it starts at 0. If I have 1 in for x, it goes to 3. If I have 4 in for x, square root of 4 is 2, and 2 times 3 is 6. So 4 for x would get me 6 out. 1, 2, 3, 4, 5, 6. So here is my original graph. Now, I'm going to translate the graph. So this sign is a negative, and that's what it should be. So I'm just going to pull out a positive 1. So every point is going to go up 1. Or, not up, sorry. It's going to go to the right 1. And then every point will go up 2. So to the right, let me change colors here. To the right 1 and up 2 would be right here. To the right 1 and up 2 would be right here. Right 1 up 2 would be right here. So now it goes like that. Now, be real careful that you don't pull this graph down here, because it doesn't go down here. That would give us a negative number under the radical sign. So it starts at this point right here and goes up this way forever. Okay? All right, graphing the translated cube root function. So I'm going to sketch the graph of the parent function for this, the -2 times the cubic root of x. And I'm going to notice that some of the points that passes through is -1, 2, and 1, -2. So this one graphs as -1, 2, and 1, -2. So it does this turnaround thing right here. Okay. Now let's do the shift for this. So this sign needs to be a negative. It's not, so I'm going to change it to a -3. So this time it's going to go to the left 3 units, and then it's going to go down 2 units. So let me change colors again. To the left, and how many units? 3 units. So that would be right here. And then down 2 would be right here. And then to the left, 3 units. Down 2 right here. And then take this point right here, to the left 2 units, down, or left 3 units, and down 2 would be right here. So now it shifts it right here. They run parallel to each other. It's just a shift over translation. Okay, go ahead and graph the parent function of these, which is graph that part first and then do the shift. And then graph this part and then do the shift. Notice that this graph is a 2 scale, so be careful where you put your points. Don't worry so much about the domain and range. We'll go over that in class.